Hello and welcome to the C++ Insights YouTube channel. I'm Andreas. I work as a C++ trainer offering classes worldwide, on-site or remote. This is my YouTube channel where I use my tool C++ Insights to teach you various topics related to C++. Today's episode is more towards performance than to anything else. I'd like to show you how to get a handle on performance like I'm talking about today with the help of C++ Insights, but I also show you other ways. This here is our entire example for today. I have a function template fun taking a single template parameter t, and it takes a parameter of type t, call that one val, and it returns it. We come later to the static assert. This is why I'm using C++23. All I'm saying is true for all the previous standards. It's just for verification purposes that I require C++23 later. My function template fun here returns auto. And I get a lot of questions during my training classes when and where and how to use auto. And as much as I'm a fan of using auto variables and using auto as return types, if you start talking about performance, and by that I mean compile time performance, my answer might be different than if we talk in a less performance-centered context. So I have my function fun here, function template returning auto. What I'm doing is I'm using fun here together with decal type. I'm invoking fun with the value 3. So if we do the instantiation in our heads, we know that the return type of fun, and with that the expansion of decal types type becomes int, right? Because 3 is an integer. I have a fancy way here of declaring a variable x of type int. This is not really the code you would write as simple as that, but in more generic code you will have code that's more towards what I have here. And the question is now, how difficult is it for the compiler to generate the code here, to parse it, to create you a binary? Not that this one will do any good. And what does the compiler have to do to reach to a working program for you? If I use C++ Insights to transform this, we can see a couple of things. So we have the primary template here, and we have a template instantiation. The template instantiation, no surprise, is for the data type int. It returns an integer, and we have a function body here that is a static cast to an R value reference of int. So we are looking at some kind of optimization here to do C++23 more implicit moves. That thing here might be move eligible. But this is not a focus on today's episode. Here now we have what we wanted, declaring a single global integer x. What is it I'm talking here when I say compile time performance? Well, what I'm talking about here is that in this scenario, as you can see it here, the compiler had to create the function body of fun. So it had to instantiate the entire function fun. Assume it's not just a one-liner as I have it here. That might be something even more time consuming. And now assume you have a larger code base than my toy one here. You might end up instantiating fun and others like that a couple hundred, maybe 1,000 times. And then whether the compiler has to create a function body or not is something that you might want to pay attention to. C++ Insights offers you a view into the compiler. So whenever the compiler instantiated a function template, there is a body that C++ Insights shows you, presents you. Whenever the compiler is only interested in, let's say, skimming the template, then there is no body. The question in the beginning was to return auto here or to return t. From the template itself, because it's so simple, we know if we take a t, we return t, so we could say t here instead of auto. If I do this transformation, then we can see one slight difference. This is a, let's call it a peak of the instantiation of fun, but the compiler is happy with just the declaration here. So no need to instantiate this entire function template and generate the body. And this is where you can save compile times if you have this pattern a lot in your code base. Just think about whether auto here is really the right thing or whether you know the return type and can be specific. Because in this unevaluated contexts, so in the previous example, right, there was nobody using this function. But this one here, it's an unevaluated context, so nobody will later be able to use this function here because there is nobody using it. This is some optimization where you can also argue if someone later uses fun with an integer as a function template, then there is nothing to optimize away. But if it's only used in an unevaluated context and you cannot be sure because of the parameter configuration, then maybe this is something where you do unnecessary work. And I wanted to prove that to you that it's true here and true for all compilers, so it's not just C++ insights generating a fancy body here. Believe me, that would be too hard to do. If I enable this static assert, which in C++ 23 we can simply say false statically, and now that one triggers because the compiler must instantiate this function template, and by doing so it stumbles over this static assert. Well, that's constantly false. If I say the return type is t, then we can see it passed. Here, no function body, no need to check the static assert, so it passes. This is why I have Compiler Explorer here. So this is the example. Let me enlarge that for you. This example from C++ Insights. You can see I used this conformance view here with the 3 compilers, GCC, Clang, and MSVC. All 3 of them in C++ 23 mode pass if I return t, and t will really stick. And all 3 of them immediately fail if I use auto. So if you want to reduce compile times, if you want to control compile times, check whether auto for function templates is really the right thing, or whether you would be better off with a concrete type because you already know it, and that could spare you a bit of compile time, which might add up to more than just a bit. I hope you like this episode, more focused on performance, and stay tuned for the next one. That's it for today. Thanks for watching.